Hello students, how are you all? Fine. So students, today I am present here for class 11 chemistry English medium students. Unit 1, some basic concepts of chemistry. So students, we have already completed the full explanation of this chapter, some basic concepts of chemistry. So now we are going to do the discussion about the solved examples which are given in your NCERT textbook, solved example problems which are given in your NCERT textbook. So students, you know that solved examples which are given in your NCERT textbooks, they are from problem number 1.1 to 1.8. So students, we are going to discuss how the examples are given, okay, solved, how the examples are given solved in the NCERT textbook. So let us see 1.1 to 1.8. So students, now we are going to see about how the examples are given, solved examples are given in your textbook, and we are going to discuss the whole explanation here. Students, this is our first chapter. Okay students, so this is our first chapter. You can see here. Unit 1, some basic concepts of chemistry. So students, already we have discussed about different concepts in the chemistry. So now we are going to discuss about problem 1.1 to 1.8. So students, here is our first problem. Problem number 1.1 to 1.8. Here is our first problem, students. So students, let us read the question what is given here. Problem number 1.1. So you know that question is given here. Calculate molecular mass of glucose C6H12O6 molecule. So students, for calculating the molecular mass of the glucose, what you have to do? You have to first know what are the atomic masses. So first you should know what are the atomic masses, and if you know properly what are the atomic masses, you have to just use the atomic masses here for each element given. So students, first of all, you should know properly what is the definition of molecular mass. So students, here you can see the definition of molecular mass here. Above this question it is given definition of molecular mass. So let us recall that definition, so you will have better understanding. So students, you can see the definition of molecular mass. See, what is molecular mass? Molecular mass is the sum of atomic masses of the elements present in a molecule. Sum of atomic masses of the elements present in a molecule. So students, in this molecule, whatever molecule we are talking about here, so here you can see in this molecule, which molecule is given? Glucose, and formula is also given C6H12O6. So by definition, molecular mass is what? It is the sum of atomic mass of elements. Now see, here there are 3 elements, okay. So we will multiply here 6 with the atomic mass of carbon, plus 12 with the atomic mass of hydrogen, plus 6 with the atomic mass of oxygen. So when you add all this, okay, you will get the molecular mass of glucose. So let us see how it has been done. So see the students, solution is given here. The molecular mass of glucose is what? C6H12O6. So how it is solved? That is equals to 6 into 12.011 unified mass. Students, you know that this 12.011 unified mass is the atomic mass of carbon element. Then number of the carbon element is how much? 6. As there are 6 carbon atom, okay, you have to multiply by it is 6. Then there are 12 hydrogen atom, and one atomic mass of one hydrogen atom is how much? 1.008 unified. Then plus 6 into 16 unified mass. So 16 is the atomic mass of oxygen. And how many oxygen atoms are there? So you know that there are total 6 oxygen atoms given. So students, as total 6 oxygen atoms have been given here in the formula, so we are multiplying 6 with the 16. So now multiply this, you will get 72.066 unified mass, then this 12.096 unified mass, then 6 into 16 you will getting 96 unified mass. Adding all this you are getting 180.162 unified mass. So 180.162 is the unified mass of glucose, molecular mass of glucose. Now students, next question. Now see what are the problem here. See what is the problem 1.2 given. Now read the question. A compound contains 4.07% hydrogen, 24.27% carbon and 71.65% chlorine. Its molar mass is given 98.96 gram. What are the empirical and molecular formulas? So students, here to solve such type of problem, okay, some steps are given. That steps you should remember. So first of all, I first explain you the steps which are given here. Okay students, see first step, conversion of mass percent into gram. So students, whatever mass percent is given here, you can see here percent mass percent, whatever mass percent is given, that this mass percent should be converted into gram. Then second step, convert into number moles each element. So whatever grams you are getting here, okay, mass you are getting in the form, in the terms of gram, that gram you have to convert into number of moles. Then what you have to do, next step is step 3, divide the mole value obtained by the smallest number. So students, you have to remember all these steps. Whatever you are getting here, value of moles, in that whatever is the smallest value, you have to divide all the other moles with the smallest value. Okay, and after that step 4 is what? Write the empirical formula by mentioning the numbers after writing the symbols of respective elements. So on the basis of the ratio which you are getting here, on the basis of that ratio of the particular atom of the elements, of the number of atoms of the elements for particular elements, so according to you that you have to write the empirical formula for the respective elements, writing symbols of the respective elements and number of numbers writing after the symbol. Then writing the molecular formula. Last step is what? Writing the molecular formula. So students, how will you write the molecular formula? If you are getting once the empirical formula, on the basis of the empirical formula, you have to find the empirical formula mass, and after that you divide the molecular mass which is given here in your question, divide the molar mass which is given here in your question, divide that molar mass with the empirical formula mass. So you will get the integral value, and that integral value should be multiplied with the empirical formula, so you will get molecular formula. So students, now let us see how to solve this sum. Okay, so first step, conversion of mass percent into grams. So students, whenever percent is given here, whenever percent is given, mass is given in percent, so you have to consider the whole sample of the given compound as having the mass of 100 gram, because you have to find out of 100 gram. So if you are considering the whole compound mass as 100 gram, then according to that, whatever the elements are present in those compound, those percent mass you can consider directly into gram. So this 4.07% can be considered as 4.07 gram if the whole compound is having 100 gram. If this whole compound is 100 gram, then this hydrogen is how much? 4.07 gram. Carbon is how much? 24.27% will be converted into gram. So students, here this is only given here. Since we are having mass percent, it is convenient to use 100 gram of the compound as starting material. Thus, in 100 gram sample of the above compound, 4.07 gram hydrogen is present, 24.27 gram carbon is present, and 71.65 gram chlorine is present. So in this way. Now see the second step, convert into the number moles of each element. So whatever you are getting here gram should be converted into number of moles. So divide the mass obtained above by the respective atomic masses of various elements. So what you have to do, students, you have to find the number of the moles of the hydrogen, carbon and chlorine in this way. So this is the mass in gram and divided by molar mass. So mass of the hydrogen in gram given is, in the given sample is how much? 4.07 gram. And what is the molar mass of hydrogen? That is nothing else but 1.008 gram. So dividing this, you are getting 4.04. In the same way, moles of carbon given mass in the compound is 24.27 gram, and molar mass of carbon is what? That is 12.01 gram. So 24.27 gram divided by 12.01 gram, you will get 2.021 gram. 2.021 mole number. Then moles of chlorine, given mass of chlorine divided by molar mass of chlorine. So 71.65 gram given mass or mass present in compound, and divided by molar mass. So molar mass is how much? 35.453 gram. So taking the ratio, you are getting here 2.021 gram. 2.021 mole. So students, this you are getting values. These are the values of mole. Now students, let us see among these three values, which value is the lowest one. So you know that these two are the same values and these are the lowest, 2.021, 2.021. So students, in next step what you have to do, you have to divide all these three by the smallest value, that is 2.021. So see the third step, divide the mole values obtained above by the smallest number. So when you divide this 4.04 by 2.021, okay, what you are getting? You are getting the ratio nearly equal to 2. Then dividing 2.021 by the same value, 2.021, you are getting value 1. Here also 2.021, dividing it by the same value, 2.021, again you are getting the same value. Again you are getting the value 1. So what will be the ratio, students? The ratio you will get in this way, 2:1:1, okay, for hydrogen, carbon, chlorine. For hydrogen is to carbon is to chlorine. So you are getting the ratio here, 2:1:1 for hydrogen is to carbon is to chlorine. Now students, what you have to do? Fourth step, according to this ratio, you have to write what? Empirical formula. So you have to, for writing the empirical formula, how will you write? How many hydrogens? 2. How many carbon? 1. How many chlorine? 1. So writing in this way, write the empirical formula for mentioning the numbers after writing the symbol of respective elements. So first write the symbol of carbon, because it will be the central atom of the molecule. So carbon should be written first. Okay, how many carbon? 1. So don't write anything. Then for hydrogen, as it is a derivative of hydrocarbon, so write hydrogen. How many hydrogens are there? 2. And write then chlorine. Then how many chlorine atom? Only 1. So write only Cl. So CH2Cl is the empirical formula of the above given compound. Now students, what we have to do? Now see, CH2Cl is the empirical formula of the above compound. Okay. Now last step, writing molecular formula. So what you have to do here, this last step is again divided into 3 steps. The step A, what is step A? Determine empirical formula mass. So what will be your first step here? Step A will be to determine empirical formula mass. So whatever empirical formula you are getting here, CH2Cl, okay, find out its mass. So for carbon 12, hydrogen 1.0, here carbon is 12.011, then hydrogen is how much? We are taking it 1.008. Okay, so there are 2 hydrogens, so 2 multiplied by 1.008, and chlorine how much? 35.453. Okay, so you have to first find the empirical formula mass. So see how we are finding the empirical formula mass. So students, here we have calculated the empirical formula mass here. For CH2Cl, empirical formula mass is how much? 12.01 plus 2 into 1.008 plus 35.453. So you are getting it equal to 49.48 gram. Okay. Now step B, divide molar mass by empirical formula mass. This we are doing to get the integral value. Okay, so molar mass divided by empirical formula mass, that is equal to 98.96 grams. Students, here in question it is given, molar mass is given here in the question. You can see in this question the molar mass is given 98.96 gram. So that we are writing here, molar mass 98.96 gram, and empirical formula mass is how much? That is equal to 49.48 gram. So when you take the ratio, you will get value 2. So this 2 is the integral value. Now see, now step C, multiply empirical formula by integral value n obtained above to get the molecular formula. So empirical formula is this and integral value is this. So what will be the molecular formula? Molecular formula is equal to n multiplied by empirical formula. That means 2 multiplied by CH2Cl. So here instead of 1 carbon, it will be now double. So there will be 2 carbon. So molecular formula see this way, C2H, H2 is multiplied by 2, so H4, and Cl is multiplied by 2, so Cl2. So in this way C2H4Cl2. This is the molecular formula of the given compound. Now students, next we are going to see problem number 1.3. So students, problem number 1.3 we are going to see here. Now students, read the question here. Calculate the amount of water gram produced by combustion of 16 gram of methane. So in order to understand this, before this theory we have already studied. So here the question is given to calculate the amount of water in gram which is produced by the combustion of 16 gram of methane. So 16 gram of methane means what, student? That is actually 1 mole of methane. If we are talking about 16 gram of methane, that means 1 mole of methane we are talking. So students, let us see. You have to burn 16 gram. You have to burn 16 gram of methane in the presence of oxygen. Why? Because combustion word is used. So what is the meaning of combustion? Meaning of combustion means to combine with the oxygen of air. So here CH4, methane is CH4 plus O2 in this way. So students, let us see the balance solution. So writing the balance equation for this reaction. The balance equation for combustion of methane is what? CH4 plus 2O2 gives CO2 plus 2H2O. So this is the balanced chemical reaction for combustion of methane. Now first see, 16 gram of CH4 corresponds to 1 mole. From the above equation, 1 mole of CH4, if we talk about this equation, this is 1 mole only. 1 mole of CH4, that will give how much? H2O. Okay, that is going to be discussed here. That 1 mole of CH4, okay, it will give how much mole of H2O? It will give 2 mole of H2O. Students, focus here. Focus here. In the reaction, here the stoichiometric coefficient is 1 and here stoichiometric coefficient is 2. That means 1 mole of CH4, okay, when undergo combustion, it will give how many mole? It will give 2 mole of H2O. Okay, so that is only written here. So it will give 2 mole of H2O. Now 2 mole of water H2O equals to how many gram? So you will calculate it in this way. 2 multiplied by 2 plus 16 equals to 2 multiplied by 18 equals to 36 gram. 1 mole of H2O equals to 18 gram H2O gives 18 gram equals to 18 gives 18 gram H2O divided by 1 mole H2O. So you are getting that is equals to 1. So actually this is what we are using unit factor, students. We are going to use here unit factor, that is 18 gram H2O is nothing else but 1 mole H2O. So yeah, we are going to use the unit factor and that's why we are multiplying it here. Hence 2 mole of H2O equals to 2 mole H2O multiplied by 1 equals to 2 mole H2O multiplied by 18 gram H2O divided by 1 mole H2O. Now students, this mole cancel out this mole. So 2 multiplied by 18 gram H2O. H2 also cancel. 2 gram 18, 2 multiplied by 18 gram H2O, you are getting 36 gram H2O. So you are getting the answer here, that when 16 gram CH4 is methane is undergoing combustion, you are getting 36 gram H2O. Now students, next problem number 1.4. questions, all of you see the question and understand it. How many moles of methane are required to produce 22 gram carbon dioxide after combustion? So what is the question? If you want to produce 22 gram of carbon dioxide after combustion of methane, then how many moles of methane should be burnt? How many moles of methane should undergo combustion? So students, now see the solution what is given. According to chemical equation, this again we are writing the same balanced chemical equation here. CH4 plus 2O2 gives CO2 plus 2H2O. Now students, we are talking about this product, carbon dioxide product. Here, if you want to produce this carbon dioxide about 22 grams, okay, then how many moles of this CH4 should undergo combustion? So students, let us see here. We know very well that 1 mole of CO2, that is 44 gram. 44 gram CO2 is obtained from 16 gram CH4. So students, when you observe the balanced chemical reaction, okay, if this is 16 gram, then it is producing 44 gram CO2. Okay, so this we are saying by observing the balanced chemical reaction. So why? Because see here written, because 1 mole CO2 obtained from 1 mole CH4, okay, and 1 mole of CO2 is nothing else but 44 gram. So students, mole of CO2. Now let us calculate the mole of CO2 in this 22 gram which is required to produce. So mole of CO2 equals to 22 gram of CO2 multiplied by 1 mole of CO2 divided by 44 gram of CO2. So students, again we have used unit factor. We are using the method of dimensional analysis. Okay, so again we have used the unit factor. Dimensional analysis, unit factor we are using here. So 22 gram of CO2 multiplied by 1 mole of CO2 divided by 44 gram of CO2. So here 22 will be cancelled out, 1 upon 2. That is equals to 0.5 mole CO2. Hence 0.5 mole CO2 would be obtained from 0.5 mole CH4, or 0.5 mole of CH4 would be required to produce 22 gram CO2. Okay, so actually this is the mole number of CO2 which are producing in this gram. Okay, so what we have done students, so first we have converted the gram amount of CO2 into mole amount. Okay, then we have compared that 1 mole CH4 is producing 1 mole CO2. So if 0.5 mole CO2 has to be produced, then how many moles are required? Then 0.5 mole only will required. So 0.5 mole CO2 would be obtained from 0.5 mole CH4, okay, or 0.5 mole of CH4 would require to produce 22 gram of CO2. Okay students, now we are going to see the next problem which is based on limiting reagent. So first of all, clearing the definition of limiting reagent. So directly I am telling you students, in any chemical reaction, out of many reaction, two or more reactants, okay, whatever reactant is in less proportion, is in less proportion or is in less amount, okay, due to which the product which is going to be prepared, okay, that product will produce in less quantity. Such reactant are known as limiting reagent. So reading the here definition also and its explanation also, and after that we are going to continue. So students, many time the reactions are carried out when the reactants are not present in the amounts as required by chemical equation, balanced chemical equation, a balanced chemical reaction. In such situation, one reactant is in excess over the other. The reactant which present in the lesser amount get consumed after some time, and after that no further reaction takes place, whatever be the amount of the other reactant present. Hence the reactant which get consumed limits the amount of products formed and is therefore called limiting reagent. So students, based on this theory, we are going to discuss the next problem. Now students, see the next problem. Problem number 1.5. See what is the question given. 50 kg of N2 and 10 kg of H2 are mixed to produce NH3. All are in gaseous state. Calculate NH3 gas formed. Identify the limiting reagent in the production of NH3 in this situation. So students, you have got 50 kg dinitrogen and 10 kg dihydrogen, and ammonia is produced from this reaction. You have to calculate the amount of ammonia in gram. Also you have to identify limiting reagent produced in this situation. So students, what we have to do, first of all you have to write the balance equation for the above reaction. Okay, so we will write the balance equation of the above reaction in this way. N2 plus 3H2, reversible reaction it is, so it gives 2NH3, again 2NH3 gives N2 plus 3H2. Then when this will combine, ammonia will produce. When ammonia decompose, then this will produce. Okay, now we are going to calculate the moles of reactant N2. The moles of N2 will be how much? So again here we are using, students, unit factor, 2 to unit factor we are using. So converting kilogram into what? Kilogram is converted into mole number. 50 kg of N2 equals to how many moles of N2? So 50 kg of N2 is multiplied by 1000 gram N2 divided by 1 kg N2, because students, these both are having same value. Okay, so ratio will give value 1. Again this is multiplied by 1 mole N2 divided by 28 gram N2. So students, actually what we are doing here, kilogram is cancel out, N2 is cancel out, kilogram N2 cancel out, kilogram N2 cancel out. Again here gram N2 cancel out. Okay, so whole terms will be in unit, mole unit. So 50 multiplied by 1000 divided by 28, you are getting this 17.86 multiplied by 10 square mole, 10 raised to 2. So this is the mole of N2. Now in the same way, moles of H2, 10 kg of H2 multiplied by 1000 gram H2 divided by 1 kg H2 multiplied by 1 mole H2 divided by 2.06016 gram H2. So here also kilogram cancel, H2 cancel, gram cancel, H2 cancel, and whole unit value will be in the unit of mole. So multiplying 10 into with 1000 and dividing it by 2.016, you are getting 4.96 into 10 raised to 3 mole after converting it into scientific notation. So students, this is the mole of N2 and this is the mole of H2. Now again we are comparing it with the balance equation. So according to the above equation, 1 mole N2 requires 3 mole of H2. Okay, so 1 mole of N2 is required 3 mole of H2. Then for 17.86 mole of N2, the moles of H2 required would be how much? So what you have to do, you have to multiply 17.86 mole of N2 with 3 mole of H2 and divide it by 1 mole of N2. So here when you do cross multiplication, you will get the required moles of H2. So 5.36 into 10 raised to 3 moles of H2 is actually required for the balanced chemical equation, but we don't have this much value. We are having only this much quantity, 4.96 into 10 raised to 3 moles of H2. So actually requirement is more and we are having this value less. Okay, so here see explanation is given, but we have only 4.96 into 10 raised to 3 moles of H2. Hence dihydrogen is the limiting reagent. So students, we got dihydrogen is limiting reagent in this case. So ammonia NH3 would be formed only from that amount of available dihydrogen. Okay, that is 4.96 into 10 raised to 3 moles. So students, from this mole of dihydrogen available, ammonia can be formed. Okay, so this is the reagent which is limiting the production of this ammonia. Since 3 mole H2, now we have to see in this balanced chemical equation, students, that again see the focus on this balanced chemical equation, that 3 moles of H2 gives 2 moles of ammonia. So students, focus here, 3 moles of H2 gives 2 moles of ammonia. Now again focus here, how many moles of H2 are present here? So comparing now, so we are doing comparing, 3 moles H2 gives 2 moles ammonia. So 4.96 into 10 raised to 3 mole H2, that is the available quantity of H2, will give how many moles? So multiplying this with cross multiplying this with and dividing with this, so it will give 4.96 into 10 raised to 3 mole H2 multiplied by 2 mole ammonia divided by 3 mole H2. So mole H2 will cancel out. Okay, 4.96 into 10 raised to 3 multiplied by 2 by 3. So you are getting 3.30 into 10 raised to 3 mole ammonia. Okay, so 3.30 into 10 raised to 3 mole ammonia is obtained. Now if they are to be converted into grams, it is done as follows. So now you see 1 mole ammonia equals to 17 gram ammonia. Okay, when you calculate the molar mass of this ammonia, 14 plus 3 into 1. So 1 mole of ammonia equals to 17 gram ammonia. So 3.30 into 10 raised to 3 mole ammonia, whatever we obtain ammonia. Okay, that will be how much gram? So that will be multiplied by 17 gram ammonia and divided by 1 mole ammonia. So mole ammonia will be cancelled here, and this 3.30 multiplied by 17 you are getting here, and into 10 raised to 3 you are getting here 3.30 into 10 raised to 3 into 17 gram. So 56.1 gram, 56.1 multiplied by 10 raised to 3 gram ammonia. Okay, so multiplied by 10 raised to 3 gram. So students, now this 10 raised to 3 is nothing else but 1000. So 1000 gram means what? Kilogram, 1 kilogram. So 56.1 multiplied by 10 raised to 3 gram ammonia, that is equal to 56.1 kilogram ammonia. So in the question the reactants are given in the kilogram. Here the product should also be in the kilogram. So students, now we are going to see about next problems, that is problem number 1.6. So students, this problem number 1.6, 1.7 and 1.8, now 3 problems are there, and these are based on this topic, that is reaction in the solution. In the reaction in the solution, here the concentration of the solution is expressed in these terms: mass percent, mole fraction, molarity and molality. So for this your definition and formula of all these terms should be clear. So students, let us see the question here. Problem 1.6. A solution is prepared by adding 2 gram of substance A to 18 gram of water. Calculate the mass percent of the solute. So how to solve this? Mass percent of solute A. Okay, already the formula is given here, students. Mass percent equals to mass of solute divided by mass of solution multiplied by 100. So here also we will do it the same way. Mass percent of solute A equals to mass of solute A, given mass of solute A, divided by mass of the whole solution, and this ratio should be multiplied by 100. So how much given mass is there? 2 gram is given, students. 2 gram substance A. So write here 2 gram in the place of mass A, mass of A, and here in the mass of solution you have to add both solute and solvent both. So 2 gram of. Okay students, now we are going to see problem number 1.7. Calculate molarity of NaOH in the solution prepared by dissolving its 4 gram in enough water to form 250 ml of the solution. So students, all of you know very well what is the definition of molarity. Okay, and you know very well what is the formula of molarity. So discussing here or using here the formula of molarity, of calculating molarity. So students, we know very well that molarity is nothing else but it is the actually ratio of number of moles of solute to the volume of solution in liter. That means number of moles of solute in a given solution divided by volume of solution in liters. So students, here number of moles of solute is not given to us. What they have given? They have given the mass of solute in gram, and we know molar mass. So students, using mass of solute in gram, given mass of solute in gram, and dividing it by molar mass, we will get the moles, number of moles. So students, writing here the formula, since the molarity M, capital M, equals to number of moles of solute divided by volume of solution in liter, that will be equal to mass of NaOH divided by molar mass of NaOH. So this ratio will give you moles of NaOH, and volume of solution in liter, that is actually, see, they have given volume in milliliter, so you have to convert this milliliter into liter. So 250 ml divided by 1000 ml. So what will get? You will get 0.250 ml. Okay, sorry, 0.250 liter. So here volume of solution in liter will be 0.250 liter. So now 4 gram divided by 40 gram divided by 0.250 liter. So here you will get 0.1 mole divided by 0.250 liter. So you are getting here 0.4 mole per liter or mole liter inverse. So this mole liter inverse or mole per liter, that is nothing else but molarity. So your answer is 0.4 molarity. Now students, you know that the molarity of a solution depends upon the temperature, because volume of solution is temperature dependent. Students, as we know that with the change in temperature, volume change. So when temperature change, the volume of solution change. As a result, what will happen? Here in the denominator the value will be changed. Okay, and due to that what will happen? The molarity of the solution will change. Now students, we are going to see the next question, that is question number problem number 1.8. So students, see problem number 1.8. The density of 3 molar solution of NaCl is 1.25 gram milliliter per milliliter inverse. Calculate molarity of the solution. Now students, what is the molality? Definition of molarity, that is number of moles of solute in a given solution, number of moles of solute in a given solution divided by mass of solvent, divided by mass of solvent in kg or per kg. So you can define the molality as the concentration of solution in which the moles of solute per kg of solvent. Okay, how many moles of solute are present in solution per kg of solvent. So that will give you molarity. Now students, how to solve this? So first of all, we have this information, 3 molar solution of NaCl. Students, what is the meaning of molar? Molar means nothing else but mole per liter. That means molarity given is 3 mole per liter. Now mass of NaCl, we have to calculate formula mass of NaCl in 1 liter of solution. Okay, so we know formula mass of NaCl is nothing else but 58.5, sodium 23 and Cl, chlorine 35.5, so 58.5. Now how many NaCl are present? 3 mole. As there are 3 mole, so we have to multiply 58.5. This is for 1 mole. So when we multiply it by 3 mole, you will get it, okay, in gram. So 3 mole multiplied by 58.5 gram per mole. So mole cancel, and you are getting 175.5 gram. That is the mass of NaCl in 1 liter solution. Now mass of 1 liter solution equals to 1000 multiplied by 1.25 equals to 1250 gram. Why? Because the density in the question is given is how much? 1.25 gram per ml. Okay, 1 ml is having this much gram. That means 1000 ml. 1 liter is having 1000 ml. 1000 ml having how many gram? So 1000 ml will have this much gram according to density. So mass of water in the solvent. Now we are finding the mass of water, that is mass of solvent in the solution. So mass of solvent in the solution, that is equal to mass of solution minus mass of solute. Mass of solution minus mass of solute. So what is the mass of whole solution? That is 1250 gram, and mass of solute is 175.5 gram. So subtracting mass of solute from mass of solution, you will get mass of solvent water. So you are getting 1250 minus 175.5, that is equal to 1074.5 gram. So now, keeping in mind the formula of molality equals to number of moles of solute in a given solution divided by mass of solvent in kg. So number of moles of solute is already given 3 molar, so it is actually what? 3 mole. So here we are writing 3 mole. See here 3 mole, so we are writing here 3 mole. And mass of solvent in kg we got here 1074.5 gram. So this should be converted into kilogram. This is how much kilogram? So just divide it by 1000, because 1000 gram equals to 1 kg. So just divide this by 1000, you will get it in kg. So kg will be this much, 1.0745 kilogram. So 3 mole divided by 1.0745 kilogram, you are getting 2.79 molality. Now students, you know that in chemistry laboratory a solution of desired concentration is prepared by diluting a solution of known higher concentration. The solution of higher concentration is also known as stock solution. So students, whenever in practical exam you are going for giving test, we examiner are preparing the stock solution for you, and you have to use that stock solution, which is the unknown solution. Note that the molality of a solution, we are actually keeping the stock solution. From that stock solution we are preparing the desired concentration which we have to give you. Okay, note that molality of the solution does not change with temperature, since mass remain unaffected with temperature. So students, you know that with the change in temperature there is no effect in the mass. Okay, so here whatever in this ratio, mole and mass will never change with the change in temperature. That's why molality does not change with the change in temperature. Thank you.